Today in Lab 4 we will be talking about rope spring mass. The objectives of this lab is to analyze the motion of a spring mass that is oscillating. The motion is of an arc-shaped motion that is similar to that of the extreme sports rope presented. The results of this lab is that the predicted motion of the mass followed the same pattern as the data received from the tracker, and the spring mass system satisfies the energy principle. Newton's second law and the energy principle are the two physics laws that the model replicates. Newton's second law finds the final velocity in the position, while the total energy shows the energy is equal to the kinetic energy plus the total spring and gravitational energies, which is the total flow of the energy in the system. The given data is from the Coursera video, which includes the length scale, which is 0.7 meters, the mass of the object, which is 0.402 kilograms, and the time between the images, which is 10.5 seconds. Also, the y directions are shown in the positive and negative directions. The origin is created right above the string, and the calibration is from this point of the origin to the middle of the mass. When the object is played in Tracker, it creates a graph showing the position over time as well as x and y values. These x and y values will later be put into Google Spreadsheet and created into a CSV file which will be used for code. In the code, it is important to put the mass of the object, which is 0.402 kilograms, the position, which is negative 0.116 and negative 0.2629 taken from Tracker, and the velocity, which is 0 because at the beginning the mass is not moving. In the interactions, it is important to add the gravitational acceleration, which is 9.81 meters per second, and we found the spring constant and the initial length of the spring, which I'll show you how to find later. Also included is L, which is the length of each interval, L hat, which is the direction of the mass, and S, which is the stretched length of the spring. The system's energies are the kinetic energy, the potential gravitational energy, and the potential spring energy, shown here in these equations. In the code, it is important to establish the period t. The period t is found by doing 5t equals 7.6. This is found by counting from crest to crest, which in my data is 5, along with subtracting the last crest with the beginning crest in the data, and getting 7.6 overall. The period was found to be 1.52 seconds. In finding the spring constant, we use the period equals 2 pi the square root of the mass over the spring constant. Then solving for the spring constant, it is equal to 6.87 newtons per meter. The initial length L naught was found by knowing that mg equals the spring constant times s. By manipulating this problem, we get the L naught is equal to 0.126 meters. In the energy system, we know that we have kinetic energy, the gravitational potential energy, and the potential spring energy. The while loop is set for the motion of the system. The initial energies are set to the variables that are used later on. The gravitational force has mg in the negative y direction. The spring force is Hooke's law. Fnet is found by adding the two forces together and is later used in the Newton's second law. The position is then updated for each velocity. The spring is then updated in the portion of the code to factor in the stretch. The changes in energy are then updated to calculate the proper values. When the model is run in Vital, it looks somewhat like this. This graph shows the y position of the observed and the modeled positions. You can see that they're close together, which shows that our predicted and our observed are quite similar. The little changes are due to drag force and different errors that are found in Tracker. The blue arrow is the spring force and the black arrow is a gravitational force as shown in the model. By commenting out a few lines of code in the code, Another graph is made showing all the energies in the system. The blue line is the change in kinetic energy, the red is the change in spring potential energy, the green is the change in gravitational potential energy. The yellow is the sum of all the energies, which is equal to 0. Answering the question of what does it mean, the energy principle satisfies the model of the system, and it does for our model. This is because the total energy, or the sum of the energies, equals 0, as shown in the graph by the yellow line. This means that energy was conserved. Answering the second what if question, the period of the oscillation is different in each the x and y direction. They are different because the equation has different values. In the y direction, it is based on the mass and the stiffness of the spring, while in the x direction, it is based on length and the gravity. That is why these are different, as shown in the graphs created on Excel. In conclusion, this lab did show the predicted motion of mass followed a similar pattern of observed motion recorded in Tracker. There were possible sources of error which were minute, which included errors in Tracker, but overall the spring mass system satisfied the energy principle. Thank you.